Welcome. I'm Bill Jacobi. I'm a solutions architect at Amazon Web Services on the public sector team, focused on Windows technologies and helping customers run Windows on AWS, including SQL Server. Today's session should be super interesting because I'm going to talk about a product that we released or announced at reInvent called Babelfish for PostgreSQL. And Babelfish allows you to run SQL Server applications on Aurora Postgres. So let's dive right in. So lots of customers have migrated their databases to the cloud. We have over 350,000 databases migrated to AWS over the last 7 or 8 years. And the pace of migration is actually increasing over time. And we have lots of large customers who have migrated as well. Most of the customers who have migrated to AWS are performing homogeneous migrations, meaning they're migrating from one type of database to the same database on the cloud. And however, we also have another group of customers. A big part of the migrations are customers who want to migrate from a proprietary engine to a different engine. They want to make a so-called heterogeneous migration from one engine to a different engine, a proprietary engine to an open source engine. And so that's part of what I'll be talking about today with Aurora, with Babelfish for Aurora Postgres. Okay, so first, why are customers interested in migrating their databases to the cloud? And I think these reasons are probably pretty clear to people who are listening here. Number one, cost. Legacy databases can be very expensive. License fees, support fees, maintenance fees. Proprietary databases or vendor-supplied databases can be proprietary without a lot of work, without trying very hard. You can end up using features that lock you into that database. And once you're tied into that database, you're paying license fees for year after year after year after year, even if you're actually not using very many features of the application. And so the licensing aspect ends up being hard to manage, ends up being costly, and the worst sort of extent of that is if you're ever audited and you need to prove how you've used your licenses and assign them to hosts and count up your cores and worst of all make up any cores that you may not have licensed. So these are some of the reasons, cost and lock-in and licensing, why people want to migrate their databases to the cloud. But there's a lot of challenges. It's not so easy migrating from one database engine to another one. And so let's talk about some of the challenges in migrating from, say, a SQL Server application on the left to an Aurora Postgres application on the right. So in this application on the left, you really have two things. You really have T-SQL, which is the stored procedure language that your application is typically making calls to create queries and create functionality out of the database. And secondly, your application is connecting to typically port 3309, 3306 to just simply to connect to your database, and your drivers are connecting physically. Now, if you want to move over to Aurora Postgres, you've got to use different drivers to connect to a Postgres engine. You're connecting on a different port. Most importantly, you're using Postgres PL/SQL, PG/PL/SQL to write your stored procedures. And that represents a lot of business logic and database logic that is not so easy to convert. Now, we do provide some services to simplify or reduce some of the friction in moving. We have a tool called SCT, the Schema Conversion Tool, which will migrate your tables and columns and also migrate your stored procedures, functions, and things like triggers and other database objects from the source to the target database. So we do, with SCT, we do provide a capability for recreating the database on an open source database, automatically creating the schema, automatically creating the columns, and also providing you with a report of the things that won't really convert over so cleanly. But we can get you, a pretty good way there using SCT. And once you've been able to create the schema on in this case PostgreSQL, then you can use our DMS service, our database migration service, to just migrate the data. and we support both a full load copy mode of just copying over all the data in bulk, and then we support a second copy the deltas, change data capture mode of copying the updates to the database that took place during the period during which you were doing the full load to PostgreSQL. So we do provide these tools, and that makes at least moving the data to a new engine a little easier. But what's really difficult is moving the application. And the reason it's so hard to move the application is because the database logic is written in T-SQL. It has to, in the past it's had to be rewritten in Postgres PGPL SQL. You might have to rewrite the application code that's building DML and DDL statements. You may have to rewrite application code that generates DML, DDL unique and specific to SQL Server, and you'll have to switch drivers. A driver that'll connect you to SQL Server won't connect you to PostgreSQL. And so these are all very difficult tasks, and developers can spend a lot of time rewriting stored procedures and application code and getting all these things just right to migrate your application. Okay, and so let's take a couple of sort of specific examples. So if I want to just create a database in SQL Server, I could use the DDL that you see here. I can just create a table with these three columns that you see. And if I hit execute, I get the table. And I can also insert a row, a record into my database, in this case a clamp, as my first and only record into the database. And if I hit execute, you can see it in the database. Now here's an issue. So now let's say that I've queried that little one row database in SQL Server. The select statement is the same in SQL Server as any other relational database, and I'll get my clamp back with a price of $12.81 and 82 100ths of a cent, 12.8182. Now, if I had the same database running in PostgreSQL and I issued the same select statement, I would actually get back something ever so slightly different. The money data type, if you notice when I created the price field, I used the data type of money, which has 4 units of precision, or 4 decimals of precision in SQL Server, but the money data type in PostgreSQL only has 2 digits of precision for that same data type. And so all of a sudden, you see that the behavior of just a simple query is different in PostgreSQL than in SQL Server. Okay, and so this is actually a big deal because I'm showing a single example, but actually there are hundreds or thousands of little examples like this where, although the languages are SQL Server SQL is an ANSI standard, and the languages do approximately the same things, and you can compare features and functions, and it might look like on paper, well, these databases are really the same, but a lot of the details in implementation, in execution, just like this example here, are very different. And so developers may spend tens or hundreds and just put in an enormous amount of time getting the behaviors of an open source database to match that of a proprietary database. So we have an approach. We have an approach on how we can solve this problem. And so imagine, if you would, that you had your application on the left. It's connecting to a TDS endpoint, T-SQL stored procedures, and we'd like to get it over to PostgreSQL on the right. And in fact, we'd like to have Aurora PostgreSQL be our target database, be our ultimate database where we don't have license fees and costs, and we can just build it once and have it run forever. So if PostgreSQL, which runs on our Aurora RDS service, is our goal, then imagine if we could connect a SQL Server application directly to Postgres. Imagine if we could connect to Aurora PostgreSQL with a TDS endpoint. Imagine if we could still use T-SQL stored procedures to query and manipulate the data in a database hosted by PostgreSQL. So imagine if we really had a bilingual database here that could speak either T-SQL or PostgreSQL and connect over SQL Server drivers or Postgres drivers, such that the application wouldn't change. The application could connect on the left side and run as is, and we've only changed the database engine, or it could run down the path on the right, and we could, for example, add new functionality to the application by enhancing it with PostgreSQL. So we have sort of a compatibility layer on the left and the ability to take advantage of open source, PostgreSQL's open source capabilities on the right. Now, if we could do this, if we could build it, your legacy application code would remain written for SQL Server. Your application at the top wouldn't change. The compatibility is what would provide the bridge to what I'm calling freedom, the ability to use any of these capabilities in PostgreSQL. And if you wanted to, over time, to get away from SQL Server and T-SQL. And so this is sort of a vision where if you wanted to, all of your application code could be developed in PostgreSQL at whatever pace you think is the right pace, and you wouldn't be beholden to licenses and vendor costs and the lock-in and idiosyncrasies of SQL Server. So imagine if you could do these three things. Well, you can, because we introduced Babelfish for PostgreSQL at reInvent in December of 2020, and we're a little closer to releasing it today. And so what do you get with Babelfish for PostgreSQL? Well, you get basically those two endpoints and that architecture I showed on my previous slide. What you get is accelerated migrations, because once you've run SCT and DMS, you've moved your database over to be hosted on Aurora PostgreSQL. And so you haven't done any work. You haven't rewritten any stored procedures. You haven't rewritten any triggers. You haven't rewritten your functions. You've just simply moved your database. And so the migration, if you will, is really quick. It's more of a lift and a shift than a migration. There's very little risk because your application continues to run as a SQL Server application with Postgres as the underlying engine. So there's very little risk that anything will break, because we're running at the TDS endpoint, we're running your T-SQL stored procedures, we're running your T-SQL functions, we're running your triggers and everything else, all your other database artifacts. And so we think that this gives you an ability to innovate, because you can now choose to use the tools, the libraries, the functions, the capabilities that are available on Postgres without leaving anything behind, without losing your investment in SQL Server, either in people, training, skills, tools. You can use all that, but you can also innovate on an open source engine. And that's sort of my last point, that we're releasing Babelfish as an open source project on GitHub with an Apache 2.0 license, which means that you can use Babelfish, you can use it to run your applications, you can make changes to it, you can use your changes, other people in the community can make changes, you can use their changes, we as Amazon can make changes, and all of this can be made available to everybody in the community to mutually, make this SQL Server compatibility layer run well on PostgreSQL. So this is what Babelfish for PostgreSQL is, and let's just dive a little more into how we thought about building this first release that we're open sourcing. So we thought about three things as three critical things that we wanted to do. The first thing is our first design tenet is no compromises on correctness. So we will return one of two things. We'll either return the answer that you would have received in SQL Server in Aurora Postgres with Babelfish, or we'll return an error. We'll never return, for example, the money data type with only 2 digits of precision. We'll either return the functionality as implemented in SQL Server, or we'll return an error, which tells us that we or the community needs to fix something. So tenet number one, no compromise on correctness. Number two, wire protocol compatibility. So you can run this with your existing drivers. You can have ODBC drivers or OLADB drivers or ADO.NET drivers from 5 years ago, and your database drivers that connect to the database will connect to Aurora Postgres from Amazon. And so you don't need to change, it's a tenet of ours that you don't need to change your database drivers, because we think that even if we provided T-SQL compatibility, if we force you to change drivers, we think that would break a lot of things, especially with older applications. And our third design tenet is interoperability. So the key point here is that there is no SQL Server mode and Postgres mode where everything runs in T-SQL compatibility, on the left side, and everything runs in Postgres on the right side. You actually have two endpoints, and you can run some stored procedures and some database functionality using T-SQL developed in tools for SQL Server, and you can run other functionality and connect to PostgreSQL using Postgres drivers and run some functionality in PostgreSQL, in PGPL SQL, and have both functionality operating at the same time. And so there isn't really a compatibility layer where we're interpreting T-SQL into PostgreSQL. It's really two different endpoints and two different engines, and they both work. And so that gives you interoperability and the ability to create functionality either in T-SQL or in PGPL SQL. So these are the three design tenets that we had in mind when we first built Babelfish. Okay, and so I sort of hinted at this, but if you've moved your SQL Server application over to Aurora Postgres, you've used SCT, you've recreated the schema on Postgres, you've used the database migration service, you've moved your data over to Postgres, your application is working on Babelfish, on the Aurora Postgres engine, and now you want to add new functionality. Well, you have three ways of adding new functionality. You can continue developing using T-SQL, using your original SQL Server drivers. Number two, you can develop new functionality using Postgres PGSQL to build stored procedures and other database logic. And you can use open source drivers to connect to PostgreSQL. In other words, you can do everything the SQL Server way, but you can also do everything the PostgreSQL way. Or third, and the point I made on the last slide, is you can use a combination of the two. And so you can develop new functionality either in PostgreSQL and call from PostgreSQL into T-SQL to create and extend functionality, or from PostgreSQL SQL, you can make calls to T-SQL and you could extend PostgreSQL capabilities through T-SQL and remain in a hybrid kind of development environment. And so all three of these are fully supported. Okay, so this is this world in which you can run SQL Server applications on an Aurora Postgres engine. And so let's sort of dig in a little bit, and can we sort of do the hard stuff? Did we build sort of a toy product or a very early 1.0 product, or have we built something that actually can be used? And I think it really is something that's useful. So these are very common, complex capabilities, important capabilities of SQL Server. Do we support T-SQL triggers? Yes, we do. Do we support stored procedures? Yes, of course we do. Do we support cursors? Do we support client-side servers? Yes, we do. Do we support server-side cursors? Yes, we do. Do we support transactions? Yes, we do. Transactions is actually an interesting example because PostgreSQL doesn't support nested transactions. That's a capability of SQL Server that's not natively supported in PostgreSQL. However, in the Babelfish code that we've made available, we support nested transactions in PostgreSQL. And so we support applications that have nested transactions, which are a very important feature. Do we support functions? Yes, we do. Do we support table value functions that return tables? Yes, we do. Do we support functions that return scalars? Yes, we do. Do we support the data types of SQL Server, like the money example or SQL_variant? Yes, we support all of those data types. When we support a data type like money, on Babelfish on PostgreSQL, we support it in the SQL Server way so that we're returning in that example the right levels of precision. Okay, and so we support all these capabilities, and we really support them in a rich way. So for example, in my last bullet point where I say that we support the SQL variant data types, we also support SQL Server collation. We also support SQL Server string rules. We also support proper comparison rules for strings. So we support these important features of SQL Server. And so I think you have an idea of what is the vision for SQL, for Babelfish on Aurora Postgres. We have this vision of a bilingual engine that will support either SQL Server or Postgres, and you can intermix the two. And we support a lot of advanced features of SQL Server in this bilingual Postgres engine. But let's actually dive into it and take a look at what we've provided. Okay, so first of all, you can see that I'm in SQL Server Management Studio, the most common tool for creating SQL Server applications. And if I can type, if I issue a select that needs to be add version, that tells me what engine I'm running on. And you'll notice I'm actually running on Aurora PostgreSQL, the Babelfish for Aurora PostgreSQL. Okay, and now let's just create the table that I showed earlier. And so let's create this table with product ID, product name, and price. And if I create that table and execute it, then then I've created this table on Postgres using SQL Server DDL. Now using SQL Server DDL, let's insert 5 or 6 or 7 records. Okay, I've now added Babelfish, etc. into my table hosted on PostgreSQL. Okay, and now let's actually switch over to PostgreSQL. So I'm running dbeaver, which is an open source tool that's used for connecting to Postgres and other open source databases. So let's start with a select version open close paren on Postgres to see what we're running on. And I'm running on PostgreSQL 11.9. Okay. And now let's look at the table that I just created using SQL Server DDL. Let's select all products by price. The limit feature is a feature of PostgreSQL. That's actually not in SQL Server. And I can see the 5 products that I've created from Postgres using Postgres. I can see those features. And so really what I wanted to say here is we have a bilingual database that responds to PostgreSQL and T-SQL and 2 different endpoints. And so now let's create a trigger on the SQL Server side. So back here in SQL Server Management Studio, set no count on means don't tell me how many rows I've returned. But whenever there's an update, after update, just do a select of whatever was inserted. Okay? And so I've created a trigger, and now let's actually do an update. And so on the SQL, using T-SQL, let's update products and set price equal to price plus 1, where, if I can type it, product underscore ID is equal to 1, which is my Babelfish product. And let's run this. And you can see that Babelfish is now 101.5555. And I guess I can execute it again, and it's 102.5555. And let's switch over to dbeaver, and let's look at the same table. So if I now do a select, you'll see my Babelfish with 102.5555. So I have a bilingual database here, and okay, let's do some more. Let's do some more playing around here. So let's go back to SQL Server, and let's look at transactions, because I mentioned nested transactions. And so if I use the tran count, I can see how many transactions, no transactions currently. And now if I create a set of nested transactions, I have 1, 2, 3 nested transactions, and I'll roll back and exit from those transactions. And if I run this, you'll notice that I wasn't in a transaction. I'm in 1, 2, 3 transactions, and then I roll back. And so on the SQL Server side, we support nested transactions on top of the Postgres engine. So we're really running SQL Server on top of Postgres. And I'm jumping into Visual Studio as my last piece of the demo because I have a .NET application that's calling this same application, this SQL application, Babelfish application running on Aurora Postgres. I've got a connection string, and I've got 2 buttons, a refresh data button that just does a select of my products. And so in .NET here, I've got my full connection string. I'm using system.data.sqlclient.sql connection to connect. My command text is selecting product ID and price and name from orders, and I'm putting that information into a data grid on my application. And so I hit F5, I refresh the data, and there you have the same data as a Windows application with 102.5555 for Babelfish. Okay, and now let's go to my second button where I want to call a stored procedure. So my stored procedure, let's create a stored procedure where I want to return all products that are less than max price. I want to set a variable for max price. And I've now created the stored procedure. And in, let's look at my code. So in Visual Studio, instead of my select statement right here, I'm going to replace that with sp get products by price. And I'm going to set my command type to a stored procedure. And I'm going to name my parameter or fill in my parameter of max price with the value that's in my text box. Okay, and so now I can run this, and if I enter a value, say 100, I'm now getting all products in my stored procedure that are less than 100, and you'll notice all 5 products have a price of less than 100, and if I type in 10, I return the only product that has a price of less than 10. So there you've seen Babelfish, the very quick tour, and what you can do with SQL Server Management Studio, and what you can do with a tool like dbeaver, and how you can connect with SQL Server Management Studio, and how you can connect with an open source tool, and how you can update a .NET application, and the SQL Server database application all runs as though it's running on native SQL Server. So let me pause here. And let me summarize for you Babelfish for Aurora Postgres. So what we're doing is we're running SQL Server applications on PostgreSQL with little to no code changes. You can keep your existing queries. You can keep your existing database artifacts. You can run those queries and use those functions and other database artifacts on PostgreSQL as the engine, and PostgreSQL will interpret them and run them correctly. You can accelerate migrations to PostgreSQL because all you're doing is using tools, the schema conversion tool, the database migration service, to move your data, and then we do the hard work of actually setting up the endpoint and running T-SQL on the PostgreSQL engine. So the migration is just moving over the data, moving over the schema and moving over the data, and then we run the application with the Babelfish product. And what that does is it gives you this bilingual database where you can continue running the SQL Server applications with the SQL Server drivers on Aurora PostgreSQL, or you have the ability to say, well, now I'd like to take advantage of some of the capabilities of PostgreSQL built into the PostgreSQL language or other PostgreSQL libraries that have been built, and take advantage of all the innovation coming from the open source community. So with that, we have lots of places where you can learn more about Babelfish and database migrations, with digital courses listed here and classroom training listed here, and our ramp-up guides and labs and white papers and tech talks, all of which can be found at aws.training/migration. So thank you for listening. Feel free to send me an email if you have questions or comments, and we appreciate your interest.